Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be going through the Paragon Active Assurance VoIP UDP Monitor Learning Byte. Alright, so here is our topology. In this topology, we have three main devices that we are concerned about. We have TA1 and TA2, which are test agents. And then we have the control center. And the control center communicates with both test agents over the management network, and both those test agents use ETH0 to connect to the management network. And then TA1 and TA2 use ETH1 to connect into the service provider production network. And so with that being said, what are we trying to do with this learning byte? Well, we want to configure a VoIP UDP task. Since this is a monitor, the duration is going to be indefinite. That's just how monitors run. The setup type is going to be full mesh. The codec we are going to be using is the GSM EFR codec. We're going to be using port 1001, and for error seconds threshold, we want to set the MOS value to 5 and the expected DHCP value to 10. Now, with this task, what it does is it simulates VoIP media flows using, you guessed it, UDP, hence the name VoIP UDP for the task. And so these flows use a specific voice codec. That's either G711, G.723, G.729, or GSM EFR. And in this learning byte, we will be using the GSM EFR codec. And so we can run this task as a hub and spoke topology or as a full mesh topology. We're going to be using full mesh for this learning byte. And so this task basically allows you to see the effect your network has on VoIP traffic. Is my network going to work with VoIP traffic is what you have to ask yourself here. And this is what this helps you do. And so to do this, we have a MOS scale. And what that stands for is mean opinion scale. And this MOS score is calculated by the task by using the jitter and packet loss of the flow. And so if you have high jitter, high packet loss, you're going to get a lower MOS score. Now with that, the MOS score can range from 5 to 1. 1 being the worst, 5 being the best. And notice how for this learning byte, we're going to set a MOS score of 5 and see how that is. Now, one thing I want to point out, it's actually really kind of hard to achieve a MOS score of 5. And so if we don't get a MOS score of 5, we'll drop it down just so we can see what it looks like when it fails and also when it passes. Okay, so when this task starts, what happens is the test agents will generate traffic at a fixed rate and also frame size. The rate and the frame size is based on what codec we're going to use. For example, if we chose the G.711 for the codec, the bit rate is going to be 87.2 kilobits per second, and the frame size will be 218, so 218 bytes. So keep that in mind how this works. It's based on the codec we used. And then with the task, we're going to set the MOS score we want and see if it actually passes. And so with that, let's go ahead and jump to the web interface for Control Center and get this going. All right, so here is the web interface for the Control Center. Let's go to Monitoring, New Monitor, and we'll create this monitor. We'll call this VoIP UDP LB for Learning Byte. And then we'll select the VoIP UDP task. And notice how this is a puzzle piece task, which means we can add additional tasks for this monitor. But for this learning byte, we're just going to focus on the VoIP UDP task. Okay, so with that, setup type, full mesh, and the clients, we're going to say TA1, ETH1, and TA2, ETH1. Now that's very important. You select the right interface for the different test agents, or they're not going to be able to communicate with each other very well. Okay, number of flows, we didn't specify that in our criteria, but we can leave that at 1, that's fine. And the codec, remember we are selecting the GSM EFR codec. And the port, let's set that to 1001. And then the thresholds for error seconds. Remember, we want to set that to 5. And then the expected DHCP value, we're going to set that to 10. Now, recall that 1 through 5 is what you can have the MOS score set to, and 5 being the best. So we're expecting the best possible results. So with that, I'm going to start the monitor. And we're going to start without a report. We don't need that here for our learning byte. If this was a production network, highly recommend you do set up periodic reports. And the monitor is getting started. It takes just a minute to get a monitor started. So it'll just be another few seconds and then we'll start seeing some results. All right, so we're seeing some results. And as you can see here, we have black, which means 50% is error seconds, 50% or more that is. And that's not good. Well, that's not what we want to see. So we have to ask ourselves, why are we getting this low score? So recall that with our error seconds threshold, we have either a MOS score that is less than 5 or a DSCP value that is not 10 that is being received. And you can see here right off the bat that the MOS score is not 5. It's at 4.3, which is still really good. 4 is good. 4 and above is actually a really good MOS score. But it's not perfect. 5 was basically perfect. So there's no packet loss, but the jitter probably isn't where we want it to be. And we can select the individual streams to get more information about this. You can see here if we remove the error second bar, the rate we don't need to be concerned about. And here you can see the jitter. We can see that, how that's popping up like that. That's not what we're liking as far as the MOS score, so that's why that's a little lower. And if we look at the table, we see more information here. We can see that we have 0 loss, so that's great. Can't have any loss. We see the jitter here. And then we have, so ES for DSCP, how much we're losing, any at all, and we're not losing any, so we're not having any problems there. But we are getting 100% error seconds, and that's because of that MOS value. So let's go ahead and close that, and then let's edit this on the fly. That's the great thing about monitors. You can just edit on the fly. And let's change this to 4 instead of 5. So recall that 4 is really good. And let's save that, and that bumps us right back out to the monitor. And this will take just a minute to update. And you can see now we're getting some more results. We can see that the error seconds is no longer black. That is the error seconds bar. We're getting green here now on both streams, and that's really good to see. And so we can select this here, and let's go to table, or we go back to graph. You can see here where the error seconds started, not being 100% in our case, and we can look at the error seconds here as well. We see it's 100%. We can scroll down there. We see it drop down to 60. And if we close that and then open it again, that should actually look a little better. We should have some additional results in there. Oh, actually, I misspoke. We're only showing errors. So let's click Show All. We should get a little better information in there. So there, let me scroll down. And then let's scroll over. And there you go. So we can see where we had 60%. That's where things are getting back to better. Then we have 0%, 0%, 0%, 0%. For that 10 seconds there, that resolution window, we had 60% error seconds, and then we dropped to 0. And the reason behind that, we have the MOS score set to 4 instead of 5 as far as what we want for the error second threshold. So things look good there. So that does bring us to the end of this learning byte. So this learning byte, we demonstrated how to configure and run a VoIP UDP monitor. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.